Number 15. For the following exercises, use synthetic division to find the quotient. So we have 2x cubed minus 6x squared minus 7x plus 6 divided by x minus 4. Alright, so we put the 4 here, that's from the x minus 4. It's always x minus k. Alright, if it says x plus 4, that's the same as x minus a negative 4, and so you would put a negative 4 up here, if that said x plus 4. So you always interpret it as x minus something. Alright, so whatever that something is, that's what you put up in the corner for a synthetic division. And now you put the coefficients of the dividend right here. You have to have a coefficient for every x term, even if it's missing. Well, let me write what this is. There's a 2x cubed, so you put a 2. A negative 6x squared, so negative 6. A negative 7x, so I put a negative 7. And the constant term is 6. Put that down. Let's say there was no x squared term. It was just 2x cubed minus 7x plus 6. You would put a 2 for the x cubed term, but you have to have a something for the x squared term, and if there is none, you would put a 0 there, okay? And then the negative 7 and the 6. So you have to have placeholders for every power that's represented in this polynomial, and even if that term is missing, you have to put a 0 there at least. But this one is nice and well behaved for us. You put a line. What you do is you leave some space under or above the line so that you can put numbers here. Alright. Now you bring down the 2. Just bring it down, don't do anything, just bring it down. Then you take 4 times 2 is 8, and then write the 8 here. And then you add these. 8 plus negative 6, or 8 minus 6 is 2. You write the answer there. Then 4 times 2 is 8. Put it there. Add those. 8 plus negative 7, 8 minus 7 is 1. And then 4 times 1 is 4. Put that 4 there. Add those. 6 plus 4 is 10. So that's your remainder, 10. Okay? So if I were to write this out, this, by the way, isn't really shown in the answer in your book, but this is actually what we just did. So here's our dividend on top, and then divided by the x minus 4. Okay, that equals, now we started with an x cubed, so this is going to be an x squared term, so that's 2x squared. The degree will be 1 less. 2x squared plus 2x plus 1, and then plus the remainder over the divisor, which is x minus 4. All right. So we put plus 10 over x minus 4. So this is the full result of the division written out for us. Alright, so that's basically what this means. All these numbers down here at the bottom. Alright. Alright, number 17. We have 4x cubed minus 12x squared minus 5x minus 1. divided by 2x plus 1. Alright, there's a problem before we start synthetic division. There's a problem with the divisor. The divisor has to be in the form x minus k. Notice this has a constant other than 1 in front of the x. It's a 2. So we can't really use this the way it's written in synthetic division. You can't put a negative 1 up here in the corner, alright? Because that is not in the form x minus k. Alright, this is ax minus k, where a is not equal to 1. Alright, so that's not insurmountable. We can massage this a little bit, as they say in mathematics. Alright, but it is inconvenient. Okay, so to do this, let me show you what's going on. I've got writing this thing out in longhand, so to speak. I've got my dividend over the divisor 2x plus 1. Alright. So what I do is I need to write this in the form x minus k, where the constant in front of the x has to equal 1. But I don't want to change the value of this fraction. If I do, then I've basically changed the problem, and I'm not justified in writing an equal sign. So I have to somehow handle that. So let's see what we can do here. 4x cubed minus 12x squared minus 5x minus 1. First thing I can do is factor a 2 out of the denominator, and that leaves me with x plus 1/2, like that, common factor. Alright. Now this is the same as 1/2 times this fraction, this over x plus 1/2. Alright, so what I can do is I can take the 2 and divide it into each of these coefficients in the numerator. Alright, so I'm going to get 2 into 4 is 2x cubed minus 6x squared, just dividing 2 into each of these, minus 5 over 2x minus 1/2. Alright? And then on the bottom I'm going to write that as x minus k, or x minus negative 1/2. Alright, so basically you're canceling the 2 with each of these coefficients here. Alright? So now it's in the form x minus k, where k is negative 1/2. And now we're going to have to deal with fractions in our synthetic division. Alright? Oh, that should be fun, right? Okay. So we've got negative 1/2 in the corner. So if you keep getting this problem wrong, you know, if you wrote a negative 1 up there, there's no way you're going to get the right answer. Okay. So that's what you have to do first. Alright, so we've got, let's see, the 2, that comes from these here, the 2, the negative 6, the negative 5/2, and the negative 1/2. And again, leave some space above that line that you're drawing. This little box here represents the remainder. So you just bring down the 2, don't do anything, bring it down. Negative 1/2 times 2 is negative 1. Put the negative 1 here. Add these. Negative 6 and a negative 1 is negative 7. Then you go negative 1/2 times negative 7 is positive 7 over 2. That's nice. There are common denominators here, so we can just add. Negative 5/2 plus 7/2 is 2/2. 7/2 minus 5/2 is 2/2, which is 1. And then negative 1/2 times 1 is negative 1/2. And then you add those, you get negative 1. All right. So let me write out the answer like I've done before. And I'm going to leave this part out and just write the answer. Okay, so you're taking this division here, and the result from here is 2x squared minus 7x plus 1. And then you've got a minus 1 over this divisor, x plus a half, minus 1 over x plus 1/2. So again, you're using this divisor here. All right. So we can manipulate this a little bit and get back to the original divisor. So we've got 2x squared minus 7x plus 1 minus, and then multiply this by 2 over 2. And that way you'll get the original divisor back again, and you're multiplying by 1, so you're not changing the answer. You're just changing its form. All right, you're not making it something else. So you multiply the remainder by 2 over 2, or 1 in other words. You can always do that and still keep it equal to its preceding line, like that. And so we've got 2x squared minus 7x plus 1, and then multiplying the 2 over 2 through, 2 times 1 is 2, so you got minus 2 over 2 times x plus a half is 2x plus 1. And so that would be the answer that we are probably looking for in the answer section. All right. Number 19. We've got 3x cubed minus 2x squared plus x minus 4. Divide that by x plus 3. So again, it's got to be in the form, the divisor that is, has to be in the form x minus k. So this is x minus a negative 3. All right, so the k there would be a negative 3, and that's what you'd put up in the top left corner when you do synthetic division. Okay, so write the coefficients of the dividend: 3, negative 2, a 1, and a negative 4. Leave some space underneath and put a line like that. Now again, some people do this or draw this a little bit differently, but it all amounts to the same thing, so it's not a big deal. All right, and so you just bring down the first number, the 3, just bring it down, and then you multiply the corner number by this number. Negative 3 times 3 is negative 9. Write the answer in the next space there. Add those two. Negative 2 and a negative 9 is negative 11. Okay. So now you go negative 3 times negative 11 is positive 33. Then you add 33 plus 1 is 34. And then you multiply negative 3 times 34 and you get negative 102. Add these two numbers, you get negative 106. That would be the remainder. So this represents, the original was 3x cubed, so that's going to be a 3x squared minus 11x plus 34 And then the remainder over the divisor, so that would be minus a 106 over x plus 3. So that's the answer to this division fully written out. Okay? Okay, number 21. This one has another divisor that we have to massage a little bit here. So let's see, we've got 2x cubed minus 7, or rather plus 7x squared minus 13x minus 3 divided by 2x minus 3. So again, it has to be in the form x minus k. The coefficient in front of the x has to be a 1, a positive 1. It's not that way in this one. So we've got to get it that way. So I'm going to write this out. 2x cubed plus 7x squared minus 13x minus 3 over 2x minus 3. I want to make sure what I write next will be equal to the previous. We've got 2x cubed plus 7x squared minus 13x minus 3 over. Now I'm going to factor a 2 out of those two terms. That gives you x minus 3 halves inside the parentheses. Like that. Common factor. And then you can take this 2 and divide it into each of these coefficients on top. So you end up with x cubed plus 7 over 2 x squared minus 13 over 2 x minus 3 over 2. And down below you have x minus 3 halves. Alright, so you write your 3 halves over here in the corner, and then write the coefficients of this polynomial, this dividend. We've got 1x cubed, 7 over 2, negative 13 over 2, and negative 3 halves. Alright, bring down the 1. 3 halves times 1 is 3 halves. 7 halves plus 3 halves is 10 halves, which is the same as 5. 3 halves times 5 is 15 halves. 15 halves minus 13 halves is 2 halves, which is the same as 1. 3 halves times 1 is 3 halves. And then you add those and you get 0 remainder. So thankfully we won't have to massage the remainder to make it to get it to look like it has this divisor like we did in that previous problem. So all we have to do is just, the answer to this division would be 1x squared, or x squared, plus 5x plus 1. Number 23. We've got 4x cubed minus 5x squared plus 13. Notice the dividend is missing an x term, so you have to watch out for that. Alright, so we're going to put a 0 for that missing x term when we write it in our synthetic division. So just be advised of that. And then you've got divisor is x plus 4, or x minus a negative 4. So you put the minus 4 up here. Now we write our coefficients, a 4x cubed, negative 5x squared, a 0x. If you don't put that 0 there, you're going to get the wrong answer. And then the constant term is 13. If it was missing the constant term, you'd put a 0 at the very end. Alright, so again, even the constant term has to have a placeholder when you do synthetic division. Okay. So you bring down the 4. Negative 4 times 4 is negative 16. And then negative 16 and negative 5 is negative 21. Negative 4 times negative 21 is positive 84. 84 plus 0 is 84. Negative 4 times 84 is negative 336. And then negative 336 plus 13 is negative 323. There's our remainder. Alright, so the answer to this division, written out, would be 4x squared minus 21x plus 84, and then the remainder, minus 323 over the divisor x plus 4. Number 25. X cubed minus 21x squared plus 147x minus 343 divided by x minus 7. Divided by x minus 7. Okay. So put the 7 up in the upper left corner. And the coefficients, you got 1, negative 21, 147, negative 343. Bring down the 1. 7 times 1 is 7. Negative 21 plus 7 is negative 14. 7 times negative 14 is negative 98. 147 minus a 98 is 49. 7 times 49 is 343. How nice. Because when you add these, you get 0 for the remainder. Alright, so it turned out very nicely, even though the numbers look kind of daunting. So this division's answer would be x squared, 1x squared, minus 14x plus 49, and there's no remainder, so that's all there is. Okay, 27. We have a 9x cubed minus x plus 2. I see a missing term that we're going to have to deal with. And then we've got divided by 3x minus 1, so this needs a little persuasion to get it into the right form. So we like our persuasion to be gentle, and so we call that a massage. Alright, so we've got 9x cubed minus x plus 2 over 3x minus 1. And I'm going to do what I did before, factor 3 out of the denominator. So we've got 9x cubed minus x plus 2, and then factor the 3, that leaves you with x minus a third. Okay, now you can divide the 3 into the dividend, so you've got 3x cubed minus 1/3 x plus 2/3. And that's over x minus 1/3. So you write your 1/3 in the corner, upper left corner. And your coefficients, that would be from this dividend up here. You've got a 3. There's no x squared term, remember that, so put a 0 for the x squared term. Then you've got negative 1/3 x, and then a 2/3. Alright, bring down the 3. 1/3 times 3 is 1. Alright, 0 plus 1 is 1. And then you got 1/3 times 1 is 1/3. Negative 1/3 plus 1/3 is 0. 1/3 times 0 is 0. 2/3 plus 0 is 2/3. So there we go. So let us write out the answer to this division, and let's see if we can get it into something that we recognize. Okay, so the answer to this is 3x squared plus x and there's no constant term, and then plus 2/3 over x minus 1/3 divisor there. Okay, so that's 3x squared plus x. And now we can write the 2/3 like this, plus 2/3 times 1 over x minus 1/3. Alright, so you can take this, if it helps, you've got 2/3 over x minus 1/3, you can write that as x minus 1/3 all over 1. Write that as a complex fraction, and you know how to deal with those, right? You multiply the numerator and then multiply that by the inverted denominator, 1 over x minus 1/3, like that. This is my scratch area here, so don't get confused. Okay, so that's basically what I have here. Alright, so if you're wondering what the heck's going on from here to here, that's what's going on. Okay, so that equals 3x squared plus x. Multiply the 2/3 through, so you've got 2 times 1 is 2, so I've got plus 2 over 3 times x minus 1/3, that's going to be 3x minus 1. And now it's written in a way that probably agrees with the book's answer. Alright, and I say probably because it's been a while since I checked when I did this work. But I do check all my answers against the book, and if I didn't make any notation about it, then I agree with the book. So that's how you get it into the way we want it with the original divisor. Alright. Number 29. Okay, that's x to the 4th plus x cubed minus 3x squared minus 2x plus 1. divided by x plus 1, or x minus a negative 1. So you put the negative 1 up here in the upper left, and you write all the coefficients of the dividend. We've got 1, 1, negative 3, negative 2, and 1. So with these long polynomials where synthetic division really shines and is a great time saver. So you bring down the 1. Negative 1 times 1 is negative 1. 1 minus 1 is 0. Negative 1 times 0 is 0. Negative 3 plus 0 is negative 3. Negative 1 times negative 3 is positive 3. 3 minus 2 is 1. Negative 1 times 1 is negative 1. And then add those and you get a 0. So there's your 0 remainder. And the original dividend was a 4th degree, so this is a 3rd degree polynomial, and the answer. So the answer for this division is a 1x cubed plus 0x squared, so there's no x squared term, minus 3x plus 1. So there's our quotient.